Bees build honeycombs by working as a unit to create hexagonal walls. This pattern results in a strong, efficient structure. But consider the ingenuity behind these individual wax cells. Each one is integrated as part of the whole, yet functions as a contained unit, so each bee can work on its tasks. That's the idea behind microservices. In short, microservices is an architectural design for building distributed, self-contained applications, allowing you to deploy services one-to-one. This allows for each service to scale or update without disrupting other services in the application, creating an opportunity to make tasks faster or more efficient. Let's take a deeper look at this state-of-the-art architecture and see how it might benefit your next project. To understand the importance of microservices, it is necessary to understand how software systems were traditionally developed. Software applications are developed according to a set of requirements, with defined inputs and expected outputs. Even as software development techniques evolved, applications were generally developed to perform within a particular operating environment with specific hardware specifications, such as CPU, RAM, and hard disk space. This method resulted in monolithic software due to the ease of shared memory and runtime environment. But with this monolith system, small changes generally require retesting the whole system. That means a change in one service can affect the entire system. Imagine the freedom of being less dependent on other services, reducing implementation time, enabling you to provide more reusable services, even as when one microservice goes down, the others remain active. Microservices provides all these benefits. Now, let's look at how they fit into the NAS. The National Airspace System is an elaborate system of systems with complex information needs. Its System-Wide Information Management, or SWIM, standardizes the data formats and provides access to data between systems. But the systems are still monolithic. Therefore, they're costly to modify to take advantage of the data exchange. That's where microservices provide a solution. Microservices architecture builds on the SWIM services-oriented architecture. It's independent, but can still access the information needed. And by isolating one function, it creates a much leaner way to accomplish the task. This architecture offers a transformative approach that achieves the goals of the next-gen vision. New applications can be implemented using microservices. Microservices should continue to use standard data formats, while SWIM can provide access and security for microservices for the larger enterprise. Decomposing the services into microservices is a complex process that will vary system to system. It requires domain experts for each system and a big-picture viewpoint for the architecture. Let's look at weather services in general. First, a functional analysis must be performed, identifying business functions that can be decomposed into microservices. From there, we create reusable and scalable microservices that can process the data individually. For a quick example, let's look at the weather conversion microservice architecture. The business services that exist inside the weather conversion services receive data from SWIM and share data with other applications. As microservices, they can be tailored by each application to process the data as needed. Each business service would be a standalone microservice to be reusable by other applications. And each microservice could be updated independently without affecting other parts of the whole system of services. While microservices build upon SWIM data, they operate on a set of tools optimized for microservices. These include API Gateway, Service Mesh and Event Mesh, and a virtual compute environment that aligns with NAS modernization strategies. The microservices architecture offers promising opportunities to the NAS, both organizational and technical. Potential benefits include scalability, shorter release cycles, improvements in maintainability, high availability, and cloud readiness. These benefits can be maximized through organizational acceptance and careful planning. And we're committed to making this architecture an instrumental component of the InfoCentric NAS. We look forward to leveraging the power of microservices in more projects and seeing new ideas take flight even faster.